All right, so this says a car travels at 32 meters per second and has a wheel radius of 36 centimeters. Compute the time in minutes it takes a point on the rim of the wheel to turn through 400 revolutions. All right, so I usually draw a picture even if it's not like essential. We should note that this is no calculator, so that must mean all the arithmetic is doable. Okay, so we'll return to that in a second. So it's 36 centimeters. Okay, and I'm given so 32 meters per second, that's a linear speed, a linear velocity. I'm gonna write that, 32 meters per 1 second. All right, so now this question says compute the time in minutes it takes the point on the rim to turn through 400 revolutions. So, we're looking for, it's like 4,000 revolutions. 4,000 revolutions per, like, we don't know how many minutes that takes, but we're basically trying to find what that t is. First of all, the linear speed's in seconds. Let's instantly turn that into minutes, just so we're in the same units as our answer requires. 60 seconds per 1 minute. All right, so now at least I've got my linear speed in meters per minute. Okay, and then again, when it comes to converting between linear and rotational speed, the key insight is that a circumference produces 1 revolution. Okay, now I need revolutions up here, so I need 1 revolution, and that's worth the circumference, which is 72 pi centimeters. Now at this point, you're probably looking to cancel something, and nothing canceled because my distance was in meters and the radius was in centimeters. So if that ever happens, it's fine. Just do one more conversion by converting centimeters to meters, and that is 1 meter is worth 100 centimeters. So now we can cross those off, and I've got my, and I can cross this off. And if you notice, I've got my answer now in revolutions per minute. Okay, so at this point, the tricky thing about this problem is it's not asking how many revolutions per minute. It's asking, the unit is 4,000 revolutions per t minutes. But let's collect what we have here so far, just to kind of work with some of the arithmetic. So it's 32 times 60. Notice it's not really essential at this point to even do the multiplication out because things could divide. And then 1 times 1 times 72 pi. Okay, so again, the units here that's revolutions, and this is minutes. Let's do a little canceling out here. I noticed that 12 goes into 72 6 times, and 12 goes into 65 times. Okay. You can simplify a little more. I think 2 goes into 6 3 times, and 2 goes into 32 16 times. All right, so cleaning that up, 16 times 5 times 100 divided by 3 pi revolutions minutes. Now look, whatever that numerator is, it's definitely not 4,000, right? So we need the numerator to be 4,000. What we'll do here is we'll just figure out, so this has got to be the same speed as 4,000 revolutions per, and then I don't know how many minutes. Okay, but these ratios have to match. Okay, the speed is the speed, however, whatever units we give it. So let's just cross multiply here. So if I cross multiply, I get 16 times 5 times 100 times t, and that should equal 3 pi times 4,000. And we divide both sides by this stuff. Okay, so that leaves behind our t, and that is the answer. We just need to reduce it. That's 500, and 500, so maybe I'll write that. That's 500. 500 goes into 4,000. Well, you can cross off some zeros. It's 40 divided by 5 is 8. Okay, so maybe just to clean it up here, now I have 3 pi times 8 over 16. Again, this is revolutions. I'm sorry, nope, it's minutes. It's not a rate anymore, sorry. we're solving for t, so in the end it's just minutes, and it's what we want. An 8 over 16, so 8 goes into 8 once. Okay, and so I'm left with 3 pi over 2 minutes.